I graph higher pupils, the next part of our addition formula notes, and this time it's using trig ratios. Okay, so our basic trig ratios we've used since our National 5. That's when we're given something as simple as sine, cos or tan is equal to our ratio, okay, our fraction. In this particular example, sine A, we're able to use our triangle, which is here on our this right hand side, and if we have our angle A, we have our opposite, which is 4, our hypotenuse, which is 5, and the final side of a triangle can be calculated using Pythagoras as 3. Okay, so that statement, sine A is equal to 4 over 5, actually gives us, with a wee calculation, all 3 sides of our triangle. And if we've got all 3 sides of our triangle, we're able to work out not just sine A, but cos A and tan A. And this can be used within our addition formula. Okay, so looking at this example here, sine A is equal to root 7 over 4. If we take that information and form a right angle triangle, we have our angle A, our trig says that's our opposite, that's our adjacent, and that's our hypotenuse. Sine is opposite and hypotenuse. So there is root 7, there is 4, and we are missing a value here. However, a third side can always be calculated using Pythagoras. So root 7 squared plus x squared is equal to 4 squared. Root 7 squared is 7, plus x squared is 16, so x squared is equal to 9, x is equal to 3. So what we have is our third side. So if we've got our third side, we can calculate our, well, we've been given sine A, and that's root 7 over 4, but we can also work out cos A. So cos A is our adjacent over our hypotenuse, which is 3 over 4. Repeat with our second triangle. So there is B, and we have our opposite, adjacent, and hypotenuse. And in this case, this is our adjacent, and this is our hypotenuse. So we have root 11, we have 6, and we have a missing side, which is y. Okay, so to calculate our y, we have root 11 squared plus y squared is equal to 6 squared. 11 plus y squared is 36. Y squared is 25, so y is equal to 5. So once again, we have our 3 sides of a triangle, and if we're given cos B, which is root 11 over 6, we can therefore work out sine of B. And from B, we have our opposite over hypotenuse, which is 5 over 6. So a wee bit of work, taken simply from the ratios, form a triangle, work out the additional side, and therefore we have the sine and cos for that angle. Do that twice, and then once we've got that, we can do our expansion. sine of A plus B. If we look at our formula sheet, we have sine of A, cos of B, consistent for sine, so plus cos of A, sine of B. And then it's a case of, let's see what we've got. So sine A, which is this one, multiply cos B, plus cos A to 3 over 4, sine B to 5 over 6. Once again, always get the consistency on our denominator, 24, and then a single fraction, 24, is as good as root 77 plus 15 over 24. Okay, so from a simple ratio, we'll be able to work out either any of the 4 formulas, sine or cos, for A, or A plus B or A minus B. Okay, and C is from homework for specific instructions from your class teacher.